Good morning. Today we are going to solve problem 3.2 from Fundamentals of Electric Circuit by Alexander Sadiku's 5th edition. So in this problem we are asked to obtain V1 and V2. By seeing this circuit we can understand that this can be solved using nodal analysis. So we are going to apply KCL, that is summation of incoming current, that is equal to summation of outgoing currents. That is Kirchoffs current law, isn't it? So we are going to apply it. And here we have two non-reference nodes. These two are the non-reference nodes. And this node 1 voltage is V1 and this node 2 voltage is V2. And this ground is the reference node. So let's assume the current flow through the particular branch and name them. So here it is named as I1 and the current which is flowing away from this node as I3, then this current as I4 and this current as I2, and the current from here is I5 and the current leaving here is I6. Okay. So now we are going to apply KCL at node 1. So at this node, incoming current is I1, that is equal to the summation of outgoing currents. What are the currents which are outgoing? I2, I3 and I4. And this I1, instead of I1, we can apply Ohm's law. So here it is 0 potential. So 0 minus V1 divided by 10 ohms. That is your I1. That is equal to I2 is, so this is I2, right? So V1 minus this 0 potential divided by 5 because it is flowing in this direction. Okay. So that is V1 by 5. Then for this I3, it is flowing from here to here. So we have to write it as V1 minus V2 divided by this 2 ohm. Plus this I4 is nothing but the 6 amps currents. Okay. So now it is minus V1 by 10. That is equal to, if you take the common denominator as 10, then here this becomes 2V1 and then this becomes 5 times V1 minus V2 plus 60. Then we can cancel out these two and we can write this as minus V1 plus 2V1 multiplying this by 5. So 5V1 minus 5V2 plus 60. So minus V1, that is equal to 2V1 plus 5V1 minus 5V2 plus 60. Thus we are bringing all these voltages to the left side. So we get this as minus V1 minus 2V1 minus 5V1 plus 5V2, that is equal to 60. So when you add these V1s together, we get it as minus 8V1 plus 5V2, that is equal to 60. This is our first equation. So now we are going to apply KCL at node 2. So here the incoming currents are this I3, I4 and then I5. So summation of incoming currents, that is equal to I6. Okay, the outgoing current. Now instead of this I3 we can apply Ohm's law. So this I3 is V1 minus V2 divided by 2 plus this I4 is 6 and this I5 is this 3 amps, that is equal to I6. I6 is this V2 potential minus 0 divided by 4. So it is V2 by 4. So we can write this as V1 by 2 minus V2 by 2 and this V2 by 4 is brought to the left side. So this is minus V2 by 4, that is equal to this 9 becomes minus 9 on the right hand side. So this is when you take common denominator 4, so it is 2V1 minus 2V2 minus V2, that is equal to minus 9. So we can write this as 2V1 minus 3V2, that is equal to minus 36. So we got the second equation. So we write this first equation and the second equation together. Now we are going to multiply the second equation by 4. So we get this as 8V1 minus 12V2, that is equal to minus 144. That is, we are going to solve this two equations. Okay, so this can be taken as modified form of the second equation. Once again I write the first equation. So when we try to solve this, this can be cancelled and here this is 7V2 when you add these two. minus 7v2, that is equal to minus 84. So v2 is equal to 84 by 7, because this minus minus get cancelled. Okay, so that is equal to 12. So we got one answer. So this v2 equal to 12 volts can be substituted in equation 2. So it is 2v1 minus 3 into, instead of v2 we put it as 12, that is equal to minus 36. So 2v1 minus 36 equal to minus 36, that means 2v1 is equal to minus 36 plus 36, that is 0. So v1 is equal to 0. So we got the two answers. v1 equal to 0 volts and v2 equal to 12 volts. Thank you.